Hello, good evening, everyone. Welcome to Pittsburgh.NET User Group. We are part of the .NET Foundation. So you can follow us on the social channels and LinkedIn, and we do have a meetup.com/pgh.net. Please follow us, and we do have monthly meetups on .NET. Today, we're going to look into replace your GitHub Actions YAML with C# using Nuke. And we have our featured presenter, Daniel Ward. Hey, Daniel, welcome.
Hey, how's it going? Thanks for having me.
It's a pleasure. And start.
All right. So, like Bala said, I'm Daniel Ward. This is replace your GitHub Action YAML with C# using Nuke. So, as a disclaimer to start this off, this will not apply to just GitHub Actions, but I kind of had to choose one for the title, and I think that's probably the most used one. But it works for Azure pipelines and Jenkins and TeamCity and a lot of stuff. And we'll sort of get into what I mean by replacing your YAML with C#, how exactly that works. The QR code on the slide here, it will also be on the final slide, so don't worry about missing it. But this just takes you to, I have a blog post on my blog up where you can find these slides. So if you're interested in going to any of the links or just seeing any of the content again, you don't have to save or screenshot every single slide or anything like that. You can just go to that post. So just to kind of give you an idea of what we're going to be going through, you can take mental notes. The outline of this presentation, the things we're going to cover what Nuke is, why you might want to use it, especially when compared to alternatives that are out there, both existing tools and YAML, right? And going off of that, we're going to go to the features Nuke has, like not just compared to the alternatives. Here are the pros that Nuke has. Here's the things it gives you. And then we're going to go over installing it, using it. We'll have a coding demo with setting up a Nuke project and actually using it, seeing what it looks like in action. And that'll be most of the presentation. After that, there'll be a couple slides, mostly about like further learning if you're interested in looking at more stuff, some cool features that might be a little more advanced that I didn't showcase. And then we'll wrap up. First of all, like Bala said, this is through the .NET Foundation. This is for the .NET Pittsburgh user group, right? But we're also going through being hosted by the .NET Virtual User Group, which is run by the .NET Foundation. So thank you to them for hosting us, giving us the additional visibility there. And also, really quick about me, as I like to call it, the best looking slide on my presentation. I'm a software developer and consultant at a company called Lean Techniques, based out of Iowa, although I live in Texas. And we do things like digital transformations, helping you get started with testing. I like that especially, helping you go to the cloud for the first time, figuring out why you can't release, things like that. I am a Microsoft MVP in .NET. And like I said, I live in Texas. I'm the co-organizer of the San Antonio/Austin.NET user group. You see two different logos there because before COVID, it was two different user groups. So there's two different meetup pages, kind of confusing. And now we act as one group currently. And you can find me online at these places. If this is all too much to remember, you can just go to my blog there, my website, taninacan.com, which is primarily a .NET technical blog. But you can find my socials and all this stuff on there as well. Okay, so let's get into it here. What is Nuke? This thing we're going to be talking about today. It is made by a guy called Matthias at JetBrains. He's been at JetBrains for quite a while now. And I would like to correct something I put in the description for this talk. I said Nuke is a relatively new tool, and I was a little mistaken. It's been around for a few years longer than I thought. I think it's around 7 years old, something like that. And I wanted to make a point of mentioning that because I do think it's important of the maturity of the tool, because being around for several years means people have had the chance to kick the tires a little bit. People are actually using it. So you can go out and see examples. So yeah, I just wanted to note that. Anyway, what the heck is Nuke? Nuke is a build automation tool. As you might have guessed from the title, the special thing is you use C# for it instead of YAML or PowerShell or whatever else. And I'm also going to mention here that since I consider this such an important and impactful part of the tool, that it comes with this collection of all these C# classes and methods that help you do really common stuff like do Docker or NPM tasks so that you don't have to write those scripts yourself. I'm going to say that's also one of the main parts of Nuke. So it's this collection of helper classes, and we'll see those in the demo. So the obvious question, I think, is why not use existing tools? Not talking about YAML just yet, but if we already know we don't want to use YAML or JSON or something declarative, there's several tools, even just for .NET land out there for things like that already. There's the things, so there's MS Build, obviously. There's psake, which uses PowerShell, Fake, which uses F#, and Cake, which does use a C# DSL, but it's not fully integrated with C# tooling, like the IDEs, and you still have to use magic strings sometimes. Now, I have not used all of these, so I'm just going to kind of go what off the creator of Nuke said. He said, our team kind of used all these tools and evaluated them, and either, we're really a C# team, that's the tool we knew. Either it wasn't in C#, that's not what we were using, or it wasn't really extensible, or like I said with Cake, it's ultimately scripting and doesn't integrate with existing tooling. So he said there wasn't really a tool like this that was just plain C# out there already. And that's what I wanted, so that I just made it. Now, this is what I kind of consider the elephant in the room here. YAML is the big thing for pipelines, right? GitHub Actions uses YAML. Probably most of the platforms use YAML. Maybe there's options for JSON, but ultimately I consider that really the same thing. So why aren't we using YAML? What's wrong with using YAML? Well, really nothing. Nothing is wrong with YAML, but I think maybe we've kind of turned it into this golden hammer, right? Where we're trying to just fit it into every use case in our build pipelines. And I think it's kind of gotten to the point where it doesn't work so well for that, right? I think JSON and YAML and declarative stuff works really well for like my app settings JSON file or my ESLint RC, stuff like that, right? I have no problem with that. What I am not as much of a fan of is when my GitHub action is tens of different YAMLs, each hundreds of lines, sometimes over 1,000 lines, right? And then the main GitHub workflow calls this action, which calls another action, and they all have these branch off into all these trees. In my opinion, YAML kind of starts to break down there a little bit, and maybe we should be looking at choosing a different tool. And if you're going to do that, I think you should just choose the programming language that you're familiar with already, because that minimizes the time for to get your value to the customer, right? So here's an illustration. Again, not saying YAML is bad, but maybe I'm just saying somewhere between this on the left and this on the right, we might have lost our way a little bit, right? So the one on the right is definitely an extreme example, but that is a real YAML file. It's for a Prometheus operator on GitHub. That being said, it is an auto-generated file, but hopefully you don't have any YAML yourself with 69,000 lines and 5+ indentations. That's probably not the most fun. I don't know if anybody saw this. I think it kind of made the rounds. I think it was November 2023. I saw it on Hacker News. But this guy, I'm probably going to say his name wrong, Felix Noor, wrote this blog post. Pretty short. It's a good read. GitHub Actions are a problem. And his point was kind of just, hey, this really popular tool we have, it's kind of impressive that it's got these glaring issues and nobody's really bothered to fix them yet. Now, the irony of that is that at the time of this writing, Nuke already existed for several years, and I just didn't know that yet. But he lays out 3 primary issues with GitHub Actions and tools like it, right? He's talking about the GitHub Actions specifically, but it really applies to like these host of tools. And the first one is that you can't run them locally, right? You have, for the most part, these closed source runners, and there are attempts like Nectos Act to run this stuff locally, but ultimately they're simulations. You got to do stuff to get your environment set up. You still are probably missing some features, and it's just extra time, right, to try to emulate what's really happening. And the second one is like it. The runner is closed source, right? Not only can you not run it locally, ultimately you don't know what it's doing. That's why they give you YAML, so you can just use the tasks they have pre-configured, right? So these first two are not true across the board for all the services, but for the most part, I think they are. So what these two things mean is, I'm sure we've all encountered this. You have a new repo, or maybe you just want to make a little change to your pipeline, and it's just a bunch of trial and error. It might take 20 plus commits of just over and over to get it working. And this is even worse if your org has things like quality or security scans on every PR, then you have to wait for those every single time. And sometimes you might be talking about several days just to get your repo up and running because you're trying to figure out the build workflow, right? And the very last one is, he just said, writing YAML is painful. It's just kind of my point before, right? There's nothing wrong with that one on the left there, right? That's easy to understand when you look at it. That's fine. But when you have these big projects with complex processes, and just kind of by nature, build pipelines are complex a lot. That's just how they go. C# doesn't remove the complexity from them, I want to point out. It just makes that complexity easier to manage, in my opinion. YAML is not really modular. It's really verbose. You have to duplicate stuff a lot. There's magic strings. You have to do a find and replace a lot. It's just error prone, and it feels bad to have to do this for complex stuff, right? So here's an example. Probably all have felt this at one point or another. And like I said, this is honestly probably one of the more benign ones. I have had easily double digits of efforts, of commits, trying to get it work over and over until you finally find that one thing, maybe your indentation was wrong, or you new lined in the wrong spot or something, and it just works. And this kind of goes into not using C#. Here is a short list of things I have actually looked up specifically for Bash. So as you can see, these are what some might call pretty basic things. I promise I'm a competent programmer in general. Microsoft, please don't take away my MVP. But Bash is not really something I use all the time. In fact, it's pretty rare, to the point where it's kind of like regex, where every single time I use it, I have to Google stuff, right? I got to look up docs, things like how to do an if condition, how to do string interpolation, how to find files and manipulate them. I don't really have to look up that stuff in C#. I use C# all the time. I know how to do stuff with it, right? So kind of in that vein, I'm going to list 3 other things in addition to the ones Felix did, 3 other cons to these. The first one, kind of what I just mentioned, for a lot of more complex steps in your workflow, you might end up calling down to a TypeScript or Bash or something file you created anyway. I've done that when I have to call the GitHub API for stuff, and I'm like, why can't I do this in YAML if that's what I'm supposed to be using for everything? Vendor lock-in, obviously, if I'm writing a GitHub Actions YAML, if my company wants to migrate to Azure later, can't really do that. I think this is probably a more rare use case, but I've seen it in cases of acquisition where like a team used to be on, Jenkins or something, and now they're migrating to something else. So with Nuke, you don't have to worry about that. You write your stuff in C#, and as we'll see later, it just generates the stuff for GitHub or whatever you want. And then you can use that or switch between them freely. It doesn't lock you in there. And finally, security issues, in my opinion, are going to be worse with YAML. Now, there's no completely eliminating this in programming. You just can't. But I think we can lessen the surface area with Nuke. So when you use a GitHub action, you're probably going to use a bunch of public shared actions, right? Because you need to do a bunch of different stuff. It's the same concept as a NuGet package or NPM package, right? It's just that with your YAML pipelines, you have to use so much more of them because you probably haven't done that stuff in YAML before. And you say, well, I don't know how to do that. I'm going to use this package. Whereas in C#, you might say, oh, that's easy. I just need to make this API call, right? And it's C# code that you've wrote yourself instead. Now, case in point of you not being able to void it, Nuke is a package itself. You're using Nuke. You're using another package in the first place, right? But at least you're only using one tool instead of who knows how many. Again, you can't eliminate it, but maybe lessen the surface area there, right? For attackers to get in, for devs to go rogue, or maybe just not update it anymore, right? So, okay, so far we've really only talked about all the other stuff, all the alternatives and YAML, but just to kind of bring it back, why again is Nuke a good choice? Why should we use it? So it's just C#, right? This illuminates a lot of the stuff, like where I looked up the bash stuff, don't have to worry about that. Where I can't run it locally, I don't have to worry about that. It's just C#. It's just a C# project. I can run that locally and see the results. Right now, it's still not 100%. For instance, if I'm developing on Windows machine, but I'm using an Ubuntu runner, there may be a difference every once in a while. So there's still that aspect. For the most part, I can run my build locally. Like, it honestly feels pretty amazing. Kind of in that vein, we have the native tool integration. I can write my pipelines just in Visual Studio or Writer or whatever, and I get code completion. GitHub Copilot helps me out. I can use whatever NuGet packages I want, right? Again, it's just C#. So running locally means quick feedback. I don't have to do the thing where wait on my company's security scans every time I push up and just hope this YAML works this time, right? I can run things over and over until I get it right locally and then push up, and has a much better chance of working off the bat. I'm not saying it'll be zero pain, but I'm saying much, much less. And the vendor lock-in, you don't have that. You write your build in C#, and then as we'll see, you can just generate the pipeline kickoff for whatever platform you want. And what are those platforms? I feel like I should note, I'm not gonna just name all these out, but I think it's got all the major ones on here for the most part. GitHub Actions, I think, is the biggest one. Azure might be next, but chances are the ones you use are on here. So, okay. So like I said, Nuke's been around for a few years now, right? That means people have had the chance to actually adopt it. So I don't know in terms of like companies who's using it. I couldn't find that information, but there's definitely big repos out there that are using it. So Avalonia, you probably heard of as UI for C#. And I just put the stars next to these to show like, hey, these are actually big established projects and they're using Nuke successfully. Fluent Assertions, or the fork of it, if you know about the whole thing that just went on with Fluent Assertions, called Awesome Assertions. Hot Chocolate, which is a GraphQL tool for .NET. And Swag, which is Swagger Generator, and Course.NET, which is like a scheduled task library for .NET. So I'll put links for these at the end of this presentation also, because these are awesome examples to look at if you're ever thinking like, how should I do this in Nuke? Are there examples to look at? And honestly, some of these pipelines are pretty in-depth and big. So you can find a lot of stuff in there. Okay, installing Nuke. Before we get into the demo, I am not going to literally show how to install Nuke because I already have it on my computer. But the Nuke CLI tool is a .NET tool. That just means it's a NuGet package that also comes with a console app installed. So practically that means you get a CLI with a NuGet package. So the way you install that is just with this command here. And I'm not on a Linux-based system, but the docs say if you are, you may also need to run this command here to get it working. So that's really it. And then we'll see. Let's actually get into the good stuff here. myself over to our coding demo. All right. So I have really a bare bones app here, nothing in it. Really, all I did was create the console template, and then I gave it a unit test project with an empty unit test. Let's, I guess, add a really simple thing just so it has a success. And our program has nothing in it. It's just the default. So we've got a really simple project here, and now we want to put Nuke in it. So how do we do that? So I've already got Nuke installed, right? If I were to run that global tool command, it would tell me it's already installed. So all I need to do is nuke :setup. It'll take me through a little wizard here. All right. So it's saying I can't find a root directory, which is correct. This is my first time using Nuke. It's going to name the project _build. The reason it starts with an underscore is kind of just the same reason that gitignore and your GitHub workflow, GitHub folder start with a dot, just so they appear at the top and to kind of tag them as metadata files, right? They're not really part of your project. It's like meta project stuff. So yeah, /build is fine. We're just going to accept the defaults for all these, and we want to use the latest version of Nuke. That's my solution. Cool. So really, it was pretty fast. It's already done. And you can see here's my new C# project here, right? My _build. And let's open up build CS. This is something I noticed with the template. Let me rebuild here. Oh, it's still going. Okay. Now this is something I noticed with the template. I don't know if this, I don't think this is an issue with my local setup. So it might just be a little bug with the template now, but it complains about this guy. So maybe he's something that used to exist. I don't know, and he doesn't anymore. But he doesn't appear to be used. So if you just remove him, then it works fine. One of the first things you might know, there's a few things that stand out, I think. One of them is this big not built here. And it's saying, hey, this build project is not part of your solution configuration. And that's correct. You don't want that, right? This is the build project. It's not actually part of the app. It doesn't need to build when the app builds, right? So I just want to point that out. That is the correct configuration. It's kind of nice. It comes out of the box that way. The next thing is this build.cs file. And you can see there's not a whole lot in here. And this is really the program CS file, and he just renamed it. So if I open up the CS proj here, you can see there is nothing at all special in here, right? This is just a C# console application. There is nothing special going on here. So the different thing here is that he changed the name to build from program, and he's inheriting from Nuke build, right? And we've even got our main method, right? That we normally do in our console apps. So what's going on here in our main is saying, hey, kick off this build class, which is the one we're in now. And you can give it a starting point, basically. And when you run Nuke, you can give it a starting point from the command line as an argument. And I have three, it calls them targets here. So I have clean, restore, and compile. If you do not give it a starting point from the command line, you just say, hey, Nuke, run. This is the default starting point. So that's what I'm giving it here. But really, our main is saying, hey, just kick off the Nuke build, and then the rest is Nuke stuff. So we'll go over this, and I'll go over it now. This is the configuration, pretty simple. If it's local, it's debug. Otherwise, it's release.
Hey, Danny.
It's the same as saying .NET configuration. I think it's like that, right? Or debug.
Hey, Danny. Yeah.
So I have a question.
Yeah, there are a couple of questions. I can throw it on the screen if you can see it.
Sure. Yeah. Oh, I can see them now. Yeah. Sebastian says, is Nuke only usable for build, or is it also possible to use it to orchestrate deployment? You can't. So as kind of we'll see in a bit, Nuke, I think, started off to replace build stuff, but Nuke is really just a make tool. It can kind of do whatever you want. It can really run anything that Bash or whatever can. So if you can run it from a script, Nuke can probably do it. It's just that it may or may not have C# classes and types for those things built out already. And even if it doesn't have those types, you can still do them. It just won't be as pretty because it's not type safe and all that, right? And then someone else asked, can you use environment variables to emulate GitHub secrets? Yes, and we will also look at that pretty soon. So great question. Okay, so we saw configuration. Okay, so we have 3 targets in this default project template, right? Clean, restore, and compile. And targets are really basically just the steps. In GitHub Actions, they would call them steps. So we have 3 steps here. First, it does a clean, then it does a restore, and then it does a compile. So enough talk. Let's actually run this, right? And we do that just by saying nuke. So let's see what happens when we run this guy. While this is running, I will also note we will go over these other files in the project too pretty soon, just to kind of demystify what's going on with all these files. Okay, so it says it took less than a second, but clearly it took a few seconds. And that's because it has to do a .NET restore on the actual _build project itself. So that takes like 5-6 seconds. But actually Nuke running took very quick. And that's because our targets are not doing anything right now. There's nothing in these execute blocks. However, we can see the order they ran in, and it did a restore. So it started and it did a restore, and then it did a compile, but it didn't do our clean. So why is that? Well, remember I said we have this default starting point here, right? And if I just say nuke and I don't give it a starting point, it uses that default one. So it started at compile, but compile wasn't the first one, right? It was restore. So how did that happen? So it did start at compile, but then it saw this depends on, which means, hey, I need, no matter what, even if I'm kicked off directly, I need restore to run before I do. So first it said, okay, then restore needs to kick off before me. Restore doesn't have a depends on, so it didn't kick off clean. And that's why you don't see it here. So this does have a before. That is not the same thing as depends on. I do think before is a little more niche. But basically, if you don't have a depends on, like you have a step that runs, and then you have 2 other steps after it that don't depend on anything, they could run in either order. It's not deterministic. So it could go A, B, or B, A. And before makes it not deterministic. Now, I don't know a use case you would use that where you wouldn't need depends on, but it's there if you need it. I'm sure there's use cases for some of that. I do also want to note for each one of these, you can go either direction. There's 2 for each one. And what I mean by that is there's depends on. I could have also done dependent for compile. And that's the exact same thing. Okay. So that can be a little confusing at first, like why are there all these ordering commands? And it's really just kind of to give you options, whatever you think is easier. I am not going to go through every single one there on the docs, but there's before and after. You can skip stuff. You can tell it to proceed after failure, all kinds of different things. Let's make these a little more interesting. Let's just put some log statements in them so we can see what's going on. And notice when I type log, it says, hey, import type Seralog. That's because Nuke already uses Seralog under the hood. It's already part of it. Can even show you here if I go to manage NuGet packages for build, filter by Seralog. So yeah, it's taking a bit, but Nuke uses Seralog under the hood. So whenever you call these built-in tasks like .NET tasks or Git tasks, they will have logging implemented already for you, and it's using Seralog. So I'll just so we can kind of see what's going on. I'll just log the name of the target here in each one. This was clean. I'm also going to make restore dependent on clean so we can see it run. And also notice when I referenced clean here, it wasn't a magic string, right? It kind of auto-filled it for me and knew what it was. And that's because it's an actual C# symbol. We don't have to use magic strings here. I could even do a refactor rename on it and name it, my whatever clean, and it renames both of them. So you don't have to do find and replace, stuff like that. Pretty great. So let's undo that. And it doesn't matter what you name these at all. It's literally just whatever you think explains the step well. So we got our logs here. We got our new depends on. I don't think we need this before anymore. Let's run our nuke again. Oops. And here's, you can see it said like restore and counting up the time there for restoring the actual build project itself. Okay, so now we can see our clean in the log here that it did run. So clean, here's our logs from Seralog. Now this still, obviously this is still not very interesting, right? So let's actually have it do the steps. And the way we do that is those built-in super useful task libraries I was talking about. So in this case, what that looks like is .NET tasks, and then I'll say .NET clean. You can give this arguments. I don't think we need to in this case. Probably don't need those logs anymore either. And this will be .NET tasks restore. And this will be, it's not called compile on this one. I think it's called build. Yep. And we could even say, if we wanted to, it calls it a configurator, but really it's just a builder pattern to set your options here. And they're all like set. And I can do set no restore, because it already depends on restore. We don't have to run that, right? Set no restore tree. And this is literally, all of these commands are really just setting flags. So on the command line argument. So this is the same thing as doing .NET build. I think it's no restore. This is equivalent. It's just that they give you a C# API to do it. So let's run nuke one more time. There's the restore time. So here, started the clean. Now it's actually doing a clean. And you can even see the commands that it ran, just in case you want to validate that you're running the right stuff, or just if you want to see what it's doing. It shows you the commands it's running. And here's my restore. And here you can see in my compile, it did get the no restore flag, because that's what I told it to do. And we don't need to do that because we just restored. So it took a little longer this time because we actually did stuff. So that's expected, right? I don't want to make this a super complicated pipeline here, but there are probably some additional things you would typically want in a real build process, right? One of those things is paths, right? It's pretty common to say, like, I need to get this file off my system, or a file in my local, in the project directory or solution directory, right? But obviously the GitHub runner isn't going to have like C users dward in the file. It's going to have its own path, and especially if it's not even the same operating system. So Nuke kind of provides a lot of useful tools for this. It's got a type called absolute path. Actually, that's pretty close to what I wanted. Let's just keep that. Let's just keep that. I don't actually have a source directory, but it's a good example. So, and it's got this thing called root directory. I can do this dot because it's on the Nuke build. But as you can see, here's just the full path to the root directory. And then you might see this weirdness going on, right? And then it gets the source folder. So not only does Nuke have some built-in stuff for you, but is kind of funny. He actually overrode the division operator on this guy so that using it actually appends paths. It's like using path.combine. So on one hand, it's a little weird. On the other hand, it reads pretty nice, right? And you could keep doing that and adding more stuff, right? So, and that's a totally valid path. In fact, let's just see what it looks like. What is a valid path here? Let's just say nuke example.app. Let's get my project directory. We'll call it app directory. And just to see what's going on, right? Let's say log information app directory. Even though this type is absolute path, it will log as a string when you get the value of it. So let's nuke again. So it was up here in my clean, I believe. Clean was kind of big. Here it is. So as you can see, it just kind of constructed that for me without me having to worry about it too much. It also provides a bunch of good helper methods for you. You can say like glob directories if you want to get a lot of them. It's not anything you couldn't do otherwise. It's just a lot of nice built-in tools to make it easier and less time consuming. So let's delete him. Actually, to illustrate something real quick, let's say even this is too magic stringy for you, right? You say, I don't want to, what if I change the name of my project? This now breaks, and it might take me a while to figure out why. So you can do this. I'll say read only, the type is solution. I'm also going to name it solution, so it looks a little funky. But these attributes is the way that Nuke injects stuff into your build. And you can even see injects an instance of solution. And this is really just a class that has a bunch of useful stuff on it. So if I could say solution dot, he's got his own path, which is an absolute path, right? You can get the name of him. Add solution, he's got some methods on him. Get projects from it, and they return you a project back, a project type. But the really cool thing I want to show you is if you pass into this attribute, I think it's source generate projects equals true. Now what I can do here, a solution dot, and it did source generation to actually get the name of my app, but it's not a magic string anymore, right? It's got an actual symbol in C# for my project type. So I think that's pretty cool, considering this is all I had to do to get that. And it just makes things less prone to breaking, really. And just let's just demonstrate that. Yeah, just keep it as app directory. And I'm going to showcase something else here. That was way too much logging going on. So I think, what is it? Set verbosity, is that what it is? And then .NET verbosity.minimal. Let's do that. Nuke that. Oh, second path must not be rooted. I think this is because I really want to do this. I have the project here, but I want the path to that project. Let's do that. It's one of those properties. I won't make you watch me figure out which property it is on there, but it's a nice tool. So you can avoid those magic strings. The next thing I would like to show is parameters. It's a pretty common thing. We have parameters and secrets into our builds, right? And actually, in fact, we're already using one here, as you can see. And this is another case, I'll hover over this one as well, of injection. You can say injected parameters, right? From the docs. And these can come from three places. They can either come from the config, the CLI as arguments, rather. They can come from environment variables, Or there's a third place. They can come from this parameters JSON file. And that's actually where this one is coming from, the solution that we used. So here's that. Let's make a new one. Let's call it, this will be fake, but API key, blah, blah, blah. And then let's inject that in. Say parameter, read only API key. Read only string API key. You do need a type. And then let's just log that puppy, API key. So we don't have to wait on this whole thing every time. Let's just run clean directly. So that's a good example anyway of showcasing not using the default entry point, calling one out directly. And now, since clean doesn't have a depends on for anything, it's only going to run clean. So as you can see, I said log information API key, and there's blah, blah, blah. So that's pretty nice because, again, this is just a C# symbol, right? The value and the, parameter itself is really only defined in one place. Everything else just uses a reference to it, right? A C# reference, no less. So again, don't have to worry about magic strings or find and replace, stuff like that. And you can even say this, is a secret, if it's a secret, right? And I know it has some tooling for protecting your secrets. I'm not sure if you have to configure that or if it just does it out of the box, but okay, I've got a password, which I won't do right now, but that's because I'm trying to output a secret. So let's make a new target here just to showcase. The targets are really up to you. You don't have to stick with these three, and you can make as many as you want. So let's just make a new one here. Let's show that. Let's say a target, we'll call it test, right? We'll say depends on compile and executes .NET tasks, .NET test. And for him, we'll say set no restore and set no build. True. And you could do a bunch of other stuff like set the test output directory, set. There's a bunch of stuff. So we won't go through all that, but just kind of to illustrate, it's got every option the CLI does. It's just in C# instead. Obviously, my tests are going to pass because I told them to, but let's just run Nuke now. And we should see our test run as well. Oh. I did not take away my secret. All right, now it's Nuke. All right, let's print out my API key again or in the compile. And then because I set the default target as compile, so it skipped the test. So I can just say .test, it knows what that target is. Probably should have set verbosity minimal on most of these. And we are now in the test. So you can see here's my .NET test, and it's doing no restore, no build. Passed 1. Everything's good. Now, pretty common with parameters in general, API keys, maybe something got updated and you forgot to change it. Maybe you just forgot to include the parameter at all. And it's used maybe in this test step. Maybe there's a publish step after this or something. And maybe all the steps before that take 30 minutes or something. It's just super long steps. Maybe they take an hour. And then you run through all that only for it to tell you, hey, there's no API key. So that really sucks. And there's a built-in way to help prevent that. And there's something called requires. It takes a Lambda. And by default, just doing this will make sure it's defined. But really, it's just C#. So you can do whatever you want in here, really, right? Right. So I'll just do this and then take away the value. And then Nuke again. And you can see nothing even ran. It just told me immediately, hey, this thing is required and you didn't give it to me. So you'd find that out one way or another, but with requires, you could potentially save a bunch of time. Right. Okay. Probably good to point out there is only when. There's two versions of only when. One is dynamic and one is static. They are both similar to required. Only when dynamic runs right before this step. So you can have a condition here. Only static will run right before the whole build. So it's not like required where it will fail the whole build if it's not true. It's just that this won't run, right? So if you think the value will change beforehand, you do only when dynamic, static if it doesn't matter. All right, so the last thing I want to get to is probably the most interesting. It's how do we, actually put this on GitHub or Azure or whatever we want. And we do that with an attribute here at the top. And GitHub Actions for this one. And just takes some parameters. So the first one is the name. I'll just call it GHA build, I guess. And then it wants an image. Actually works fine. And we'll say on. And then just say any, I just want to see this run immediately. So we're going to say any push. I want to see this guy run. And invoked targets is going to be test. So that way everything else will run because of these dependencies. And then if I wanted to, I could even say import secrets and say API key, right? Just make some up, but it'll be good to illustrate. So from this, Nuke will actually generate your GitHub Action YAML. So to generate it, Nuke needs to run somehow, but it actually doesn't need to run your build. So kind of a trick for this is just to do Nuke help, and that'll force it to generate your YAML here. And we'll kind of see what that looks like. All right. So now we now have a CI folder, and here's our GHA-build. So we do still have a GitHub action, but this is the whole thing. It's 38 lines, right? So like I said, it's on push, like I asked for. It's using Ubuntu latest. So it still does a checkout action because you have to do that. It caches my NuGet packages for me, which is nice. And here's the secret I asked for, right, which just comes from GitHub. It's a GitHub secret. So the person who asked that question, I hope that answers it for you. And you can see all the GitHub action is really doing is running this build.cmd and giving it a parameter of test. So what is the deal with that? So this is what I was talking about earlier when I said I would explain some of the files in here. So in this boot folder, there's these 3 build files, which if you happen to look in the project you're on your own time later and get confused because this boot folder does not actually exist, it is a virtual folder just made to make it easier for you when you're in an IDE. But really, they are at the root of the solution here, just sitting out. Anyway, it just kicks off this build.cmd. And all he does is kick off a PowerShell. right? So there's PowerShell and SH, and they both really do the same thing. All they do is ensure that the .NET SDK is installed on the machine, because Nuke is C#. So if the runner itself doesn't have .NET, you won't be able to run your build, right? And they usually have .NET installed already, but not always, and sometimes it's not the latest one. So this just ensures it's there, right? So all the GitHub Action is really doing, right, is it makes sure .NET is installed, and then it kicks it off from this point. At this point, it's running your C#, right? So let's kind of put our money where our mouth is and actually see this running in GitHub. And just FYI, there are other attributes for other services. So you could do Azure Pipelines, and it would be similar, right? So Azure Pipelines image, Ubuntu latest, and it's similar. You can say invoke targets and import secrets. And you can have, actually, let's run them both. I've got a pre-made one here. Let's plug him in. And I guess he's not going to want to work, but I mean, it's pretty simple. Say build. Say Azure Pipelines image, Ubuntu latest, Azure Pipelines image, Windows latest. Say auto generate is true and invoke targets starting from test. And let's run help again, just to kind of see it generate both of them together. And it will be right here in this CI folder. So now I've got an Azure Pipelines build, right? And he is a little longer just because Azure Pipelines works differently. So the idea is whatever it generates for you works out of the box, and really it's just kicking off your C# stuff, right? So I haven't used Azure Pipelines in a bit, but it looks like in this case, it might actually be divvying them up, kicking them off individually. But regardless, it's kind of cool that it knows how each one works and does it for you. So I'm going to end off this demo here. I'm just going to do this. It's just a little bash script I wrote that makes a repository for me on GitHub. And I did that in the wrong folder, but I do really want to show you it running on GitHub. Select. All right, well, I don't want to make you have to sit and wait. So don't worry, I did actually prepare. And I have an example one out there already. So it's just the exact same thing I have locally. And you can see it all runs under one little node here, but you do get pile. You do get like legit logging here. Here's Nuke. And then it even collapses it like you normally would get in GitHub Actions, and it colors stuff, and you can see stuff as it happens. So something I have not done yet, but I know is possible, is you can even do remote debugging. You can set up an SSH session and actually get breakpoints in your local IDE when your remote build is kicking off. So that's pretty cool. Yeah. So one last thing I do want to show you is you can do nuke -- plan. And we'll go back over to the PowerPoint. This one is really useful for bigger pipelines. This one is pretty simple, right? It's just 4 little targets. But let's see, should give me, oh, well, maybe not. They might have changed what it's called, or I'm calling it with the wrong dash plan. So not sure. Could be, yeah, I don't know. So that's okay. What happens is it gives you a little, because it wants me to pick an app to open it with. Oh, Windows. Okay, just once. It gives you an actual HTML page, and this is my pipeline, right? And you can actually hover over each one of these, and it'll tell you what will execute. So if I hover over compile, I say, I'm going to start from compile. Well, remember all the dependencies. It's telling me, hey, it's really going to run clean, restore, and compile. So that is pretty neat. And remember the .NET tasks I showed you here? I would just like to note there are a bunch of these for common stuff. So if you go to the Nuke build docs and you go to common tasks, executing CLI tools, it's got this exhaustive list of supported tools. And they got, like, I'm not going to go through all these because there's a ton of them, but they got Chocolatey, they got Docker. That's a big one. And you can see these are all the supported commands. They've got Git version if you need to version your stuff. Kubernetes. One of the things I really like to have is Pulumi. So I think it's pretty cool. You can just Pulumi up right from your build and Nuke. You've got Unity stuff. So all this stuff is built in without even, you can just use C#. You don't even have to touch the script stuff, right? So I think that's awesome. All right. So I know we only got a few minutes left here. So let's close out this PowerPoint here. It's going to make me go all the way back. All right. So these are a few things, just kind of other really cool stuff if you want to dig into it yourself. You can share these builds, right? It's pretty common in an organization to say, we want all of our repos in our GitHub org, for instance, they have to use this action or something, right? Well, these are just C# projects, right? So you can export them as NuGet packages and share them, or you can share them as .NET global tools, and people just install them just like I installed Nuke. And they come with all their dependencies and everything. There's the remote debugging I talked about. And finally, it's got some social integrations built in. So it's got Slack, Teams, Twitter, and Gitter, useful for announcing like, hey, a build succeeded or a build failed, right? So pretty simple. You need your webhook. You tell it what you want to say, and that's pretty much it. Everything else is built in. I will give some cons just to be transparent here, right? GitHub Actions, the YAML, is more popular, and probably true with the other, big 3 or big 5 or so services as well. So that means when you Google or the docs or stuff, or just blogs, videos, resources, there's going to be more of that stuff for GitHub Actions if you find yourself stuck. I think if you're just using C# with Nuke, you'll find yourself stuck less, but it's something to consider. If your org is not just a .NET shop, you have multiple languages across the teams, you won't be able to intersource and share your knowledge as much, right? If a team is using Java and they say, hey, other team, how'd you do this in GitHub Actions? They can't tell you because they say, oh, well, we used Nuke. We didn't use YAML, right? So that could be a disadvantage. And finally, in my opinion, GitHub Actions, YAML, and just the similar services, if you don't know those at all, I would learn those first because they're just good to know for your own career. Those are going to look good on your resume. People are probably going to kind of expect you to know those at least a little bit. So I would recommend being familiar with that before you dive into Nuke. And here's some links if you want to look at the PowerPoint later. Here's those repos of some pretty in-depth. I've already got it open here. Nuke build. So here's the Fluent Assertions repo, and you can see he's got a .nuke folder. Here's his build folder. Here's his build CS. And just this is quite big, right? So he's got a lot of targets. He's doing some other stuff, which is kind of cool. Like he's actually installing Node in his .NET build. So these are just really good examples of things that are possible and how to do them. Oops. And that's it. So like I said at the beginning, you can scan this QR code if you would like the slides and take any more questions if there are any. And if not, thank you again, Bala and .NET Foundation and Pittsburgh .NET User Group for having me.
Perfect, Dan. Thank you very much. Appreciate your time. And it's been pretty good session. Don't see any other questions. I think it's a pretty good wrap. Thanks everyone for joining us. We'll see you again next month. Thanks again.
Yeah. Thanks everyone for joining.